Okay, today we're going to look at solving exponential equations. So an exponential equation is some sort of equation that has x as your exponent, or part of the exponent. So for example, if we have something like 5 to the x, that's what we'd call an exponential form. And so if it's an equation, it's going to be equal to something else. So this is a pretty basic, easy one. You could figure it out, just that 5 to the power of 2, 5 squared, would be 5 times 5, which is 25. So we already know the answer is going to be x equals 2. But let's use a method that will work for harder type questions as well. So in this case, what we want to do is we want to try to make both sides have the same base number. So on this side, we've got our 5 to the x, so that's good. So if we change our 25 to have the same base, so that would be 5 to the power of 2. And once we have bases being the same, that means the exponents have to be the same. So in this case, if both 5's are the same, that means our exponents have to be the same as well. So we would get x equals 2 as our final answer, which we already knew was correct. So that's kind of the method we want to use to solve these. So for example, let's try a harder one. If I give you 3 to the x plus 2, and that's going to equal 27. So what you want to do is ask yourself, can I make both sides have the same base? So 3 is already simplified as far as it can go. So there's nothing you can do there, but we can change the other side to 3 to the power of 3. Now that you know that the bases are the same, we can kind of ignore the bases and just solve the tops. So x plus 2 has to equal 3. Subtract 2 from both sides, and x will equal 1. You can always plug these back in, so you could take that x equals 1, go back to the original. So that'd give you 3 to the 1 plus 2 is 3, 3 to the 3 is 27, and we know that that's correct, so we're done the question. Okay, so let's try a few different ones with different types of scenarios. So if I gave you 4 to the power of x, and let's suppose that's equal to 1 over 64. Okay. One of the exponent rules are, if you have a fraction, like 1 over 64, that's the same thing as 1 over 4 to the power of 3, right? 4 times 4 is 16, times 4 again would be 64. And when we have it as a fraction like that, that's the exact same thing as having 4 to the power of negative 3. So our negative exponent law just means you write 1 over. So we can do the reverse here. So in this case then, both bases are 4. X will equal negative 3. Another weird case is when we have square roots. So for example, if I gave you, let's do 5 to the x plus 4 equal to square root of 125. Okay, so if it's a square root, do the same thing. So square root of 125, let's leave that out for a minute, but we know that 125 would be 5 to the power of 3. And now we can get rid of that square root. So the rule for exponents with square roots is a square root of x is the same thing as x to the 1/2. So we just change it to a fraction 1/2. So in this case, that'd be the same thing as 5 to the 3/2. Or let me rewrite that a little bit so you can understand a bit better. So that'd be 5 cubed, and the square root would make it to the half. And then we can put those two exponents together by multiplying them. So we'd have 5 to the 3/2. So now we know our x plus 4 will equal 3/2. Subtract 4 from both sides. So 1.5 minus 4 would be minus 2.5. So you can write it as a fraction, decimal, whichever. So if you did it as a fraction, it would be negative 5/2. So whichever doesn't matter whether you do decimals, fractions, however you want. Okay, so that's pretty much it for exponential equations. The idea is always try to make them so they have the same base, and once you have the same base, then you're ready to solve. So it doesn't matter too if you have x's on both sides of the equation. So something like this. Still do the bases the same, so we want to change the 8 to 2 to the power of 3. And the rest of our exponent stays the same. Change the 4 to 2 to the power of 2. The rest of our exponent stays the same. Multiply out or expand out your exponents, we need to multiply by both of those. So we'd have 6 minus 9x, and on the other side we'd have 4x minus 2, right? Multiply both of those. Now our bases are the same, so now we just have a regular equation to solve. So let's bring the 4x to the other side. So that'll give us 6 minus 13x equals negative 2. Let's bring the 6 to the other side. So we have minus 13x equals negative 8. And our last step, divide by negative 13. And we're done. So it doesn't matter how complicated the question is. The idea is always try to make your bases the same and then solve from there.